Okay, we have here something from MIT 2020, number 14. We have this integral of 1 over x minus 1 plus this kind of fraction of two sums right here, dx. Okay, I was looking back, I noticed I did this problem before 2 years ago, and today I want to do it with a different method. And the last one, what I did was I actually just separated this into two integrals because we know how to do this, and this one is actually not too bad on its own. Doing something different on this one, what I want to do is get a common denominator. And to save some writing, let's just put some labels. I'll call this bottom, the denominator sum, as S1. And for this one right here, let's call this S2. So to get a common denominator, I'm just going to multiply S1 over here, and then x minus 1 over x minus 1 here. So when we do it and put it together, we have x minus 1 S1 for the denominator. Then with everything multiplied out, we're going to have an S1 here, multiplying that in there, plus this becomes x minus 1 times S2. Now first, let's go deal with this denominator. What I want to do is kind of just expand it out to get a feel for it. So this thing, it's just a geometric series. I'll do it in reverse. Instead of starting at 0, let's start at 2019. It doesn't really matter how we order it. So if I write out some terms, it's going to look something like this, but it's going to be like 2020 terms. So eventually we get to like x plus 1. But for this thing, we have a formula. We have this, if we have x to the n minus 1, we can factor this as x minus 1 times x to the n minus 1, n minus 2, all the way down to 1. So what we have on the right side is exactly in this form right here. So we can do it just like adding plus 1 to the power here. We can write this expression as x to the 2020 minus 1. So what we'll do is we'll rewrite the integral with that denominator. And then for the numerator, I'm actually going to distribute it out, like distributing in the x minus 1. So we'll have x sub 1 plus x s sub 2 minus s sub 2 dx. Okay, now with our numerator all written out, again, this is s sub 1. Here we have the, I took the s sub 2 right here and we split it into two sums, like distributing in the minus sign, breaking up as we had k plus 1. So that part split up, and then this one right here is x s sub 2. Now we can take this x and multiply it inside the sum, just incrementing the exponent right here. And then staying with this one for a second, let's do an index change. I can subtract 1 on k everywhere here, and then I just need to add 1 here and here. But then looking at it like this, we're in pretty good shape because these two are almost the same. We're just off on the top index. This one goes to 2018, this one goes to 2019. So this is going to create one extra term. You could strip it off of here or add it on here. Either way, we just have this extra 2019 term. So what that's going to produce is just plugging in. It's going to have together, this is going to be 2019 x 2019. And then we can do the same thing, grouping this one with this one. Same thing, x to the k, geometric series. The only thing is this one goes to 2018, this one goes to 2019. So stripping out a term of this one, what's going to come out of this is x 2019. So to put this together for our numerator, we just need to add these two. 1 copy plus 2019 copies. This is going to be the same thing as 2020 x 2019. So let me just take this, we can plug it back into the numerator, and then we can finish it off. Okay, so now we're basically done. We could do a u substitution, but let's actually do it in our head because we have it where this right here, if this is our u, then the numerator is exactly our du. So this is just going to be an integral of du over u. So we'll go ahead and integrate on this. And so for my final solution, we get just natural log absolute value x 2020 minus 1, add a plus c, and that's it. Okay, so there you go. Good one from MIT 2020. Thanks everyone for watching. Have a good day.